Okay, we are going to start where we left off. A rectangular sunroom is 3 feet longer than it is wide and has an area of 154 feet. Find the dimensions of the room. That means the length and the width. Dimensions. Alright, so it's a rectangle, so we draw a rectangle. Alright, it says that the length says it's 3 feet longer than it is wide. So we don't know the length or the width, but we know that the length is 3 feet longer than the width. So if the width is x, the length is x plus 3. It tells us that the area is 154 feet. That means length times width. Remember, the area of a rectangle is length times width. Alright, so area, which is 154 feet, is equal to x times x plus 3. Now we multiply that out and we get a quadratic equation. X squared plus 3x. Alright? To solve a quadratic equation, you put everything on one side and set it all equal to 0. So if we subtract 154 on both sides, we are going to get 0 equals x squared plus 3x minus 154. Alright? That equals 0. Either way, the 0, it doesn't matter which side of the equation the equal sign is on. Alright, so our A, if we're going to use the quadratic formula to solve this, our A will be 1, our B will be 3, and our C will be negative 154. So, quadratic formula says negative B plus or minus the square root of B squared minus 4AC all over 2A. Alright, so negative B, that's negative 3, plus or minus the square root of B squared, so 3 squared, which is 9, minus 4 times A, which is 1, times C, which is negative 154, all over 2A, and A is just 1, so 2. Alright, if you multiply this out, you've got negative 3 plus or minus the square root. This turns out, if you add it all up, it turns out to be 625 all over 2. So this is negative 3 plus or minus 25 over 2. Now, if you do negative 3 minus 25, you're going to get negative 28 and over 2, which would be negative 14, and you can't have a negative width. So we have to add, we have to just, that's not going to be a solution. Even though this equation has 2 solutions, this problem doesn't have 2 solutions because this is about something real and it has a positive width. Negative answer does not go with this problem. So negative 3 plus 25 is 22, divided by 2 is 11. So x is 11 feet. So that's this, and so the room is 11 by 14. So that would be the answer. Alright, falling objects. The position equation, S equals negative 16t squared plus v sub 0 t plus s sub 0 is used to model objects which fall short distances with little or no air resistance, where s represents the height of the object in feet, v sub 0 represents the initial velocity of the object in feet per second, and s sub 0 represents the initial height of the object in feet, and t represents the time in seconds. Alright, that just means that if you drop an object from a certain height, alright, this equation will represent where the object is at any time after you drop it, how high off the ground it is. Alright, so the letters in this equation, the S at the beginning of the equation on the left side of the equation represents where the object is at a certain time, t. Alright, so if you drop the object off a building, where is it after 2 seconds? Where is it after 3 seconds? That's what the S right here represents, is how many feet off the ground it is. V sub 0 represents the object's initial velocity. Alright, so initial velocity means how fast is it going? Do you shoot it off the building down, or do you just drop it? And then S sub 0 is the initial height of the object. How tall is the building or the place where you drop it from? How high off the ground is the object when you start? Okay? So that is called the position equation. You do not have to memorize that. If this was a physics class, I would probably make you memorize it, but I'm not going to make you memorize that. But you will have to use it. A construction worker, I don't know why I can't seem to type right, accidentally drops a wrench from a height of 235 feet and yells, "Look out below." Could a person at ground level hear this warning in time to get out of the way? No, the speed of sound is 1100 feet per second. Alright, so the question is the sound that he makes yelling going to reach the ground before the wrench? Well, I think it should be pretty obvious to you that sound travels faster than just, almost anything. So, that wrench is not going higher than the speed of sound. Alright, but just to do the math, let's do it. Alright, so if it's going 1100 feet per second, and it's got 200, his voice, I'm talking about the sound of his voice, it's traveling at 11,000 feet per second, the speed of sound. Alright, if it's got 235 feet to go, you can see that's not going to even take 1 second to hit the ground. Okay, now you could, say, okay, well, rate times time equals distance. So the rate of the sound is 1100, and the distance it's got to go is 235 feet. So t would be 235 over 1100, which is about 1/5 of a second. So 235 divided by 1100 is about 0.21 seconds for the sound of his voice to hit the ground. Okay, so the question is really kind of a silly question, but let's see how long it takes the wrench to hit the ground. Alright, so we've got our equation, S equals negative 16t squared plus v sub 0t plus s sub 0. We're trying to figure out the time it takes for the wrench to hit the ground. Alright, so the s that we're looking for, remember s represents how high off the ground the thing is at a certain time, and we're trying to figure out how much time does it take for it to be no feet off the ground, okay? 0 feet off the ground. When does it hit the ground? So we want that to be 0. And then we're looking for time t. V sub 0 is the initial velocity of the wrench, and since he dropped it, he didn't, it wasn't going at a certain speed at that point, then the initial velocity is just 0. So 0 times t. And then s sub 0 is how high it was off the ground when we started, and that's 235 feet. Alright, so 0 equals negative 16t squared plus 235. This just goes away because it's 0 times t. And then if you add 16t squared to both sides, you get this. And then you divide both sides by 16. So 235 divided by 16 is going to be about 14.6875. And, yeah, that's t squared. I divided both sides by 16. I just looked at it. Take the square root on both sides, and you get that t is about 3.83 seconds. So, yeah, his voice definitely reaches the ground before the wrench, and whether or not people have enough time to get out of the way kind of depends on how fast they are. So that's how you use that addition equation. Alright. From 2000 to 2010, the numbers of internet users, I, in millions in the U.S., can be approximated by the quadratic equation I equals negative 0.898t squared plus 19.59t plus 126.5, where t is between 0 and 10, where t represents the year with t equals 0 corresponding to the year 2000, according to the model, in which year did the number of internet users reach 200 million. Alright, so in this equation, I is the number of internet users in millions, okay? So when it says in millions, that means that you don't write, for I, you don't write 200 million. You write 200 because it's already in millions. In the way they've set this equation up, that is how it is. It says I is already in millions. So you just put 200 for I, the number of internet users. And then the rest of the equation is just like what it is, negative 0.898t squared plus 19.59t plus 126.5. Alright, so trying not to hit this. There we go. Alright, so all you have to do is subtract 0 on both sides. Subtract 200 on both sides because you want everything on one side and you want it all set equal to 0 so that you can use the quadratic formula to find t. Alright, so subtract 200 on both sides, you've got 0 equals negative 0.898t squared plus 19.59t And then you got 126.5 minus 200. So that's going to be minus 73.5. Now, obviously, you're going to plug this into the quadratic formula to solve for t because you can't factor that. All right, so t equals negative b, so negative 19.59 plus or minus the square root of b squared, so 19.59 squared minus 4 times a, which is negative 0.898, times c, which is negative 73.5, all over 2a, which is 2 times negative 0.898. So that's something fun to plug in your calculator. Actually, it won't be fun at all. Of course, your answer needs to be positive. You'll get 2 answers because you'll get the answer you have when you do plus this and minus this. And the one that's positive is the one that's the answer to this problem because you're looking for the year that there were 200, what's the year going to be when there's 200 million users? All right, so if t sub 0 is the year 2000, you punch all these numbers in to your calculator and you're going to get some value. That number will be, it will be, like maybe 12, let's say. That would mean 2012. I'm not going to punch all that into the calculator for you because I think you know how to do it. So, one more application in 1.4. There is an L-shaped sidewalk from the athletic center to the library. The length of one leg of the L is twice as long as the length of the other leg. The length of the sidewalk which cuts across the grounds between the two buildings is 32 feet. How many feet does a person save by walking on the diagonal? All right, so they've given you the picture. You don't even have to draw it yourself. It's a right triangle that you're dealing with here. One of the legs is x feet long, and the other longer leg is 2x, twice as long. And then the hypotenuse, which represents the fast way to walk from here to here, is 32 feet. All right. So what we're going to do is see how many feet you save. This is the question. How many feet does a person save by walking on the diagonal? So if you're going to walk, you can walk this way on the sidewalk over here, or you can walk on the diagonal. All right. So the distance on the sidewalk right? Remember, this was x and this was 2x. So the distance you would walk on the sidewalk would be 2x plus x, or 3x, whatever that turns out to be. The distance you would walk on the diagonal, if they tell you, is 32 feet. Right? So you've got to find x so that you can see which is long, how much longer it is to walk on the legs of the triangle instead of on the hypotenuse. So to do that, you're going to use the Pythagorean theorem, which says a squared plus b squared equals c squared. So x squared plus 2x squared equals 32 squared. So x squared plus 2x squared is 4x squared is 32 squared. So 5x squared is 32 squared. Divide both sides by 5. And, first you would, well, that's okay, you can do it this way. So you get x squared equals, now 32 squared, if you punch that in your calculator, this is 1024, and then 5 is what you're going to divide by. So that's going to be 204.8 feet. All right, so it's way longer to walk all the way around there. Let me just double check that, make sure. Okay, so that's that's x squared. So you take the square root of that, and you are going to get 14.3 about feet per x. All right. So the question is, how long is it to walk this way on the sidewalk? That's 3x. So 3 times is going to be 42.9 feet. And to walk on the diagonal is 32 feet. So how many feet does a person save by walking on the diagonal? Well, you would subtract 42.9 minus 32. And that would be just 10.9. So you're saving almost 11 feet by walking on the diagonal. So that is the end of 1.4, and the next video will start with 1.5.